You guys?
Good morning. My name is Vladimir. I'm Seth. For our final project, we did a autonomous robot called Explorer. The system requirements for the robot is to control the robot independently of anything, like from computers or external aid. The system will receive data from 2 sensors at the front of the robot. Also, the board will control 2 DC motors also at the front. Once the sensors detect an obstacle, the robot will start a procedure to avoid such object. This is the software diagram. Once the system starts, it starts receiving data from the sensors. Then it will initialize the motors. Once it does that, the system will see if an object is being detected. If both sensors detect something, the system will stop, reverse, and then turn slightly. If one sensor only detects, like the left sensor, it stops, reverses, and it turns right. If the right sensor detects something, it stops, and it reverses, and it turns left. This is the hardware diagram. It's similar to previous labs. The microblades, the RAM. 2 GPIOs are used. One to receive data from the sensors, and the other one to receive data from the motor.
And then the HP5 ref comp, we'd like to thank Digilent for providing basically the IP core. It was just a matter of adding it into the program. Took over all the pulse width modulation that was necessary. So thank you, Digilent. Yeah, two custom IP cores using for the motors. The motor data controls how fast it goes in which direction. So design overview. Use the microblades, 2 HP5s to control the motors, and then the LS1, kind of a misnomer. It's not a detector, it's the interface for detectors. It didn't really require, I mean, with the previous page, it didn't really require anything special for it. The sensors will basically just treat as on off, so if it detects something, it immediately sends in on signal, doesn't detect anything off signal, so pretty much as simple as a switch or button. And then software, we just ran it using the internal clock. And integration and testing. Testing procedures, basically first test to make sure the pieces worked and figure out how to use them. So we used switches to control the motors to guide them around, and then used we just basically plugged in the sensors and then waved our hands in front until we could figure out what the range was. We eventually figured out the range of the sensors was rather pathetic, so you'll see when we do the demo, but we've got 2 infrared LEDs placed on top of it to increase the range. And after those 2 things, it was basically a matter of doing tests to calibrate the speeds, because one of the motors ended up being slower than the other one. So tests to calibrate, and then after that was testing to make sure it works. And that's it. Any questions?
How did you integrate some more sensors into the system?
Just Just 2 infrared sensors.
Just add it in and then combine the signals, or
No, they each have a different line in.
so they modified it?
Hmm. Any other question?
Can you see it drive?
Hmm. Then I guess we do demo now. So, have it right here. It should be effective. Just put some random things in the way. So, here we go. Turn it on, let it wake up first, and then for safety's sake, we actually have a switch on here that tells it to stop, to stand still. So take that off, and then there we go. One of the annoying things about the sensors is that they will not detect anything that's right in front of it. So, come on, see it now. Come to me. And then also include another thing, in case the wheels do not move for a period of time, it'll detect that and then move backwards. This is in case it runs to a wall and for some reason gets jammed. And that is everything.